Good morning to all. I'm Dr. Veena Priyadarshini, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the phase modulation. So this phase modulation is also a type of angle modulation. So here it is falls under the continuous time modulation scheme. So here we can say that when a signal it has three components: amplitude, frequency, and phase. And when a modulator is there, there are two inputs. One is the message and the carrier. So message is a low frequency signal as well as a continuous time signal. Here we have considered the message as the sinusoidal waveform, and the carrier is also a sinusoidal waveform, but it will be a high frequency signal. So when these two signals are passed through the modulator, the output will be phase modulator, the output will be the phase modulated signal. So by definition, we can say that the phase of the carrier signal is get varied in accordance with the amplitude of the message signal. So here also the phase, the carrier signal is get varied and message signal will remains as such. And since it's a phase modulation, only the phase component of the carrier is get varied, and the other two, that is the amplitude and frequency of the signal, remains constant. So this can be explained in this figure. So the graphical representation of phase modulated waveform. In first of all, the first signal, which is the message signal. So it's a continuous time signal. The signal is a low frequency, so it is continuous for the given time duration t. The AM is the amplitude of the message signal. So here we have considered a sinusoidal waveform. The second one is the carrier signal. So carrier is also a sinusoidal waveform. It's a continuous time signal, and the signal which is the signal will be remains continuous throughout the time duration of t. So since it's a high frequency signal, it has more number of cycles within the same time duration. Now these two signals are transmitted through the modulator, that is a phase modulator. Output will be the phase modulated waveform. So here we can say that different phase angles are used to indicate the phase variations. So in case of continuous time phase modulated signal, the positive cycle of the message signal is indicated by one phase, and the negative cycle of the message signal is indicated by another one phase. That is, for message signal, for the first positive half cycle, we are representing the signal as a low frequency signal, and next, for the negative half cycle, during the negative cycle duration, the phase is another one phase. We have indicated by another one phase, and further it increases, and next once again the positive cycle is there, so it is indicated by other frequency. So in case of increasing the frequency number of cycles is get varied. So the phase of the modulated wave has infinite number of points, so where the phase shift in the wave can takes place. So the instantaneous amplitude of the modulating signal which changes the phases of the carrier signal. When the amplitude is positive, the phase change is in one direction, and if the amplitude is in negative, the phase changes in opposite direction. So next is the mathematical representation of phase modulated signal. So first of all, consider the instantaneous phase. The instantaneous phase is indicated by phi I. So the equation for instantaneous phase in phase modulation is given as phi I, which is equal to Kp into m of t, where Kp is the phase sensitivity and m of t is the message signal. The standard equation of the angle modulated waveform is S of t, which is equal to AC cos 2 pi f c t plus phi I. So when we substitute the value of phi I in the above equation, S of t is equal to AC cos 2 pi f c t plus Kp into m of t. So this is the equation of PM waveform. So if we substitute the value of message signal here, message signal is AM cos 2 pi f from t, then the above equation becomes S of t is equal to AC cos 2 pi fct plus beta into cos 2 pi f from t, where beta is the modulation index whose value will be del phi minus Kp into AM. And del phi is the phase deviation. So thus the expression for PM waveform is explained here. So next, the phase modulation. Application of the phase modulation, it can be used in mobile communication system, while frequency modulation is mainly used in FM broadcasting. Thank you.